Alright, welcome to Chapter 9, Quadratic Equations and Functions, that states. This first one that you see right here is one that we're going to be using more exclusively towards the end of Chapter 9 when we're just doing our solving stuff. This one right here we're going to be using for our graphing, which is a little bit earlier in the chapter. The f of x right here is called a function of x. It is a little bit more advanced when you get to high school. So for example, it may be function of x, f of x, g of x, h of x. Sometimes you have to graph more than one. But for right now, we're primarily going to focus on just y equals related to what we've already done. And if you notice, they all have a's in front of the x squareds. And right here, it clearly states that a cannot be equal to 0. The reason is, if a is equal to 0, then you cannot have an actual quadratic equation or quadratic function. So go ahead and look at the whiteboard, and if you notice, I got posted up there that we have several different objectives that we're going to be working on. First one is going to determine if we actually have a solution or no solution, and this is relation to the actual graph. And then we'll look at our other objectives in a few minutes. So what I have here for you is just a sketch. I need you to go ahead and do the best that you can. You don't really have to label the numbers if that's going to slow you down. So just make a nice x-axis with your arrows. Make a y-axis with your arrows. And then you're going to make a U-shaped graph here that are called parabolas. Please highlight, underline, whatever you need to do to recognize the importance of the word parabolas. So some basic information that we need to know is listed right here. If your graph is opening up or opens up like we have right now, then the a value from the previous slide that we saw, the number in front of the x squared, the a value has to be positive. Or, going backwards, if the a value is positive, then you know the graph that you're going to have to create is going to be a graph that opens up. So make another sketch, and if you notice, it's still the same idea with your x-axis and y-axis. The numbers are not as important as you would think just right now initially. You really want to just get a sketch for the graph where this U-shaped graph is actually, as it states right there, is opening down. It's still a parabola, but again, it opens down. That means the a value is going to be negative, or again, if you're creating your own graph and the a value is negative from your equation or your function, then your graph, once it is complete, has to open down, or opens down as it states right there. Give you another moment, about 10 more seconds to complete your sketch. So just a little bit more important information before we get to our first objective where we're determining if we have a solution or no solution. The vertex, go ahead and highlight that, is the center of the graph. And more importantly right here, this is where students really understand the vertex. It's either the lowest, meaning at the bottom, or the highest, meaning at the top, point on the graph. The point again refers to what we've already talked about in the past. It is an actual ordered pair, an x coordinate and a y coordinate. Remember, the x still is going to go first. And what you've already listed, but you may want to list one more time, highlight it, make it awesome, referring to your a value, states again, if it's a positive a value, the graph opens up. Or if the graph opens up, then the a value is positive, back and forth. And the other way states that if it's a negative value for a, the graph opens down, or if the graph opens down, the a value is negative, back and forth. So finally, getting to our first objective here, we're going to determine if this is going to be a solution or not. If you notice, there is no x part, because on a standard form of a quadratic equation, it says ax squared plus bx plus c. So for more information pretty soon, this is going to be our a. Our b is missing in the middle because there's no x, and this negative 10 is going to be our c value. So I'm going to go ahead and take my coordinate there, 3, 8. My x is 3 and my y is 8. and I'm going to go ahead and plug in those values. So again, on my next line, instead of writing y, I'm going to write 8. My x is now a 3. Notice how it has parentheses for my substitution. We're going to go ahead and use some of our 7th grade skills right now, our PEMDAS idea. And if you remember, our exponents do come first before multiplication. Parentheses, yeah, we have parentheses, but we can't do anything inside. I must do my exponent first. Instead, please do not do 2 times 3. That would be incorrect. That's a common mistake that students do in Chapter 9. So as I square it using 7th grade skills, I'm getting a nice 9. Now I will use my multiplication. Again, just 7th grade skills. And then my super awesome elementary schools with subtraction. So I do get 2 numbers that are equal to each other. Therefore, I'm going to say it's a solution, just from mathematical reasoning. But thinking more about with our graphing coming up, what do you think this means? What does a solution mean when you think of a graph? Now, we've asked this question previously. You may not remember the result or the answer to that idea or that question, but I'm going to give you a moment to think about it. What does this mean when you think of a graph? So you're thinking about this equation. In the future, we will graph it, specifically with this ordered pair. So if you thought of it correctly, you would say that this ordered pair is on the graph. Can't say line because this is going to be a U-shaped graph, so it's a curve. So please write that down. Next to what does this mean when you think of a graph, please write down the point is on the graph. The point is on the graph. We're going to do the exact same skills here, but if you do notice, your B, the x part, is there. So for future practice, my A value is -1. My B value is +2. And my C value is -4. That's going to be really important next section and pretty much all throughout Chapter 9. So again, I'm going to do the exact same skill. I'm going to plug in those values. So remember, your x always comes first, and this is always your y. So on the next line, please write your -3. Now you got to be a little bit tricky here with the x part. You're going to put a negative sign, bring it down, and then you're going to plug in your 1 with parentheses. Don't forget your exponent. And then you're going to put a +2, and then your x is going to be a parentheses 1. Your -4, of course, will just stay the same. Give you time to do that if you haven't already done so. Now remember, we're still going to use our 7th grade PEMDAS idea. Parentheses, I've got parentheses, but I can't do anything inside. I've got exponents, so I'm going to go ahead and do my exponents right here. It simply just tells me 1 squared. Now remember, this negative sign here is not affected, so just bring it down. Now some people, super advanced students, they like to do the multiplication of exponents here, 1 squared, and then they also like to do this here. It's truly up to you if you want to wait to do that step. So if you notice, I did my 1 squared to say 1, brought down my negative sign, and since I'm super awesome like you guys are as well, I just went ahead and did +2 times +1, and I said +2. Now last part again, dealing with positives, negatives, you may have to use your number line, truly up to you. Again, I'm trying to see if I get -3. So you can do -1 plus 2, which is -1, or sorry, it's +1, and then -4. Or you can do -1 and -4 to give you -5, and then add 2 to get -3, whatever case you'd like, but it does work. So I am going to say solution again, just like example A, and I'm going to ask you to write down the question again. Thinking about this graph and this ordered pair on the coordinate plane, what does solution mean when you think of a graph? It should be pretty much the same idea as example A. It means that this ordered pair here is on the U-shaped graph called a parabola. So please write that again. The point is on the graph. Or you can say the point is on the parabola, which is a U-shaped graph. So we got one more solution type question. We want to know if it's a solution or a no solution, and then we'll move on to our next objective. So I'm going to do the exact same thing. Let's see. I've got my values. I'm going to plug them in. This is my x. This is my y. For future reference again, please think about it with me. The a value is 2, positive 2. My b value is negative 1. And my c value is positive 1. Again, that's going to be used in the future. So I take my values, I plug it in. Be really careful right here. It says negative x, or the opposite of x. So I put the negative sign, minus sign, and I plugged in my x value. Now again, like on example A, don't multiply this first. You're going to use the exponent. So you can say negative 2 quantity squared really means negative 2 times negative 2, or positive 4. If you want to do this at the same time, negative times negative will give me a positive 2 in that location. Again, my PEMDAS skills, and that's what I was just talking about. So negative 2 times negative 2, which is the quantity squared, gives me a 4. So I continue my multiplication here. If you notice, I already did multiply this here to give me a positive 2. And then I just continue on. And it gives me 11, which obviously is going to be a no solution. What I want you to think about it right up here, though, if you had done it incorrectly right here and said negative 4, and then when you squared negative 4 times negative 4 is 16. So right here would be a 16 instead. Anybody willing to admit that you had a 16 initially? You would then have 16 plus 2 plus 1 would give you a 19. So therefore you would have said solution, which would have been wrong. This is a no solution statement. So my question again is, what does this mean when you think of a graph? So this ordered pair in relation to this parabola, U-shaped graph, what does that mean? Now solution meant it was on the graph, it was on the parabola. So what does a no solution mean? Please write down, the point is not on the graph, because it's a no solution. The point is not on the graph. And that really helps us when we talk about our shading. If you remember what we did recently, you're going to be shading parabolas in high school when you have inequality parabola graphs. All right, we're starting our next objective, which means I'm going to ask you to determine if the graph opens up or down. This is really helpful for test-taking strategies, as well as when I'm asking you to graph the problem completely on your own, which will be in the near future. So we're going to take an equation given to us. Sometimes it's y equals, sometimes it's f of x, and we want to make sure it's in standard form. We learned about standard form in Chapter 7, which simply means, again, do I have it in the correct form, meaning x squared, x, and then your number. Of course I do. So let me think about my future stuff again. This is my a value because it's in front of x squared. This is my b value, it's in front of the x, and this is my c value. You may need to flip back to your notes at the beginning. What did I tell you about the a value? You even sketched it. We said if the a value is positive, what type of graph do you have? Open up or open down? And we're going to say opens up, and the reason is a is positive. See how easy that was? But again, that skill, very, very important for when we do some future problems. So let's do another one on this slide here. Y equals, maybe f of x equals g of x, h of x in the future. Our a value is negative 4. Our b value is negative 2. And our c value is positive 6. So again, the way to determine if it opens up or down is to look at your a value. So right up here it said opens up, A is positive. So if A is negative, what do you think? Opens down. Now a little cheesy thing that I learned that some students really find helpful is if a student is positive, generally they are happy. And what do happy people do? Happy people smile. So you would smile in a U-shaped graph or an opening up graph. But if students are negative, oh, life is so horrible, I hate it, school sucks, he said it. A is negative, life is so negative, they are always so sad, they are frowning, which means they're not smiling, but their mouth is forming an upside down parabola. Again, pretty cheesy, but very helpful to help you out. We have one more on this objective. If you notice, it's not as easy because y is not equal to my quadratic equation. So I do need to fix some stuff before I can determine if it is an opening up or opening down graph. So the thing I'm going to decide to do is put my y on the other side. So I'm still going to keep the same order, negative x squared plus y. I'm just going to switch sides. You should notice my 3x plus 2 is still going to stay the exact same way. So again, all I did was change sides, switch sides there. To get it to be y equals, I need to move this x squared value. It's currently a negative, so I need to go ahead and add x squared to both sides. Now when I add it to both sides, remember ultimately it's going to appear in front of my x value. So I'm going to go ahead and use my inverse operations. I'm going to move the x squared by adding it. Notice how I'm already kind of placing it where I think it's going to be, in front of the x value. Remember, standard form tells me x squared, x, and then number. So I just write it like that. Y equals, and then I have x squared. Since my 3x is positive right here, I do make it a plus 3x, and then a nice plus 2. So now I use my new skills. My a value is a hidden 1. My b value is a 3. And my C value is a 2. Again, identifying that ABC is going to be really helpful pretty soon. So since my A value is positive 1, what type of graph do I have? Does my parabola open up or open down? And put your reason, please. You should have written that the graph opens up because the A value is positive. A is positive. All right, we're going to look at our third and final objective. We're going to have some basic ones and maybe a little bit more advanced ones. I need you will be able to identify the vertex of the graph and give the minimum or maximum value. Now, out of this idea, the more important part is the vertex. The minimum or maximum value is helpful, but it's not as important as the vertex. Now, if you flip back or remember, the beginning of your notes, I said the vertex was either the highest or the lowest point. So if you notice here, if you think about the highest point, it would be still going on. My arrows are not present. Sorry about that. So I'm going to think about my lowest point here. This is my lowest point. That is going to be my vertex. Vertex is the lowest or highest point. So I need to go ahead and put a dot where that is located. If you have trouble seeing it, I'm going to put my dot right here, and that matches up with my -1 for the x-axis and my -4 for my y-axis. And that's going to be very important. So I'm going to go ahead and list it out. I'm going to say vertex is -1, -4. Again, all I did was put a dot there. I look up for my x, which is -1. And I look to the side for my y, which is -4. The vertex, again, is probably the most important point on the whole graph. When we learn how to graph doing all the work, that's going to be our center point as well. The next idea is your minimum or maximum value. So it says the min or max value is the y value of the vertex. So if you notice, the y value of your vertex located right here, but you need to determine if it's the minimum or maximum. So what you want to think about it is all of your y's, reference to your y's. So starting at the lowest point, if I go up my graph, either way it doesn't matter, but if I go up my graph, this goes to -3, -2, -1, 0. My y's now become positive, 1, 2, 3, and so on. So my y's are increasing as I go up the graph. So thinking about my vertex, is that going to be the minimum or the maximum for my y's? Since it's at the bottom where all the y's are smaller than way up here, I'm going to say it's going to be the minimum value. So please, next to your vertex, write minimum -4. Again, that's not as important as some other stuff, but it is helpful, some helpful information. So I got the same idea. If you notice, it's a very small portion of the coordinate plane, so go ahead and make this beautiful sketch with me. Again, you're just going to go ahead and approximate where the numbers are going to be. So again, I'm looking at my graph. I'm trying to talk about my vertex. My vertex is my lowest or my highest point. So I'm going to put a dot there. If you notice, it is the highest point, the top one. So I'm going to say my vertex is -2, 6. Remember, my vertex is found from this point. I look down this time for my x-axis, which is -2. I look to the side for my y-axis, which is +6. So I say my vertex is -2, 6. Now I think about the other part, which is the minimum or maximum. So I look at my point, and going down the graph, the y's are getting smaller. -3, -2, -1, 0, -1. I'm talking about the y-axis because it's the y values. So my vertex for the y value, is that going to be the minimum or the maximum? Since it starts out at the top and goes down and gets smaller, this is going to be the maximum value for my y's. Again, I just look at the y value for my minimum or maximum idea. But again, the vertex part is the most important. The last thing I want to discuss with you, 2 mini examples, is the domain and range. And again, this is not as important as the other stuff, but it'll be very helpful for you later on in high school. The domain is referring to your x values. So it states right here, the domain, it goes left or right, left and right, and it's the x-axis again. So if you're thinking about it, if it would start all the way up here with my vertex, your x-axis is referring down here. So technically it starts at 2, and then it goes right to 3, right to 4, going down, and so on. If you were to go this way, it goes left to 1, left to 0, left to -1. Again, I'm just looking at my x-axis. So as you imagine, this graph, it just keeps going out. If you had more paper or a bigger computer screen, it could just keep going on and on and on. My range is the part that goes up and down, and that refers to the y-axis. So again, if you were to start up here, you're looking at the y-axis. Now the y-axis is limited because if you notice, there's nothing above here referring to my y's. So in order to find the domain and range of a proper parabola, if you remember the x's, it's just going to keep increasing, going out in the left and right direction. So I'm going to say it's all real numbers, which includes fractions, decimals, roots, mixed numbers, integers, and so on. Because again, the graph just keeps increasing, going left and right. It gets going. My range, however, again, it has a limitation on it. It doesn't go up above here at all. So I'm going to say my range is going to refer to my y's, and if you notice, all the y's are smaller than the 5. Or we're going to say the range y is less than or equal to 5. It starts at the 5, and then it just keeps going down. That's why it's less than or equal to, because it starts at the 5, it's got the equal part, and as it goes down, it's the less than part. Again, just some helpful information. All right, last one. You guys have been a great audience. Again, it's the same idea. You don't have to write it down again, but domain goes left and right. The range goes up and down. Think about this vertex right here. The range is the same idea. The domain is the same thing. It's going to keep increasing, going left and right. So the domain is the easy part. It's all real numbers. For a proper parabola, opening up or down, the domain is always going to be all real numbers. For my range, again, it refers to my y value of the vertex. So if you notice, it starts at the 6, and then my range, my y's are increasing. It goes to 7, goes to 8, goes to 9, and so on. So my y's are getting larger, or bigger, or greater than the starting point. The starting point's at the 6. So I'm going to say range y is greater than or equal to 6 because the y values are increasing as you go up the parabola. And again, this is just a reflection back to the vertex, which we said was our lowest point, our highest point, our middle point, and so on. All right, so you're going to spend the remaining time working on your assignment.